Welcome to a new test and teardown video. This time it's a programmable attenuator from the company Wilsonics model PATT. So maybe that stands for programmable attenuator. It looks like they can do AC or DC. We've got 6 buttons on the little display. And 4 of them in a 19-inch rack unit like this. And it looks like you can take a screw here and take each module out. I'm of course going to experiment with that in a second. Beautiful brushed aluminium case. Okay, so it is, wow, it's aluminium welded in one piece. Wow, that is beautiful. So we got signal, ground as chassis, maybe. Input, output, I think they can be cascaded or ganged together for more channels or something like this. We got some banks and boxes and stuff like this, and where I got those from, they got a lot more and they were connected together with the flat cables and stuff. So chassis, power, ground, minus and plus 15. I love it when people do stuff like this. Now I know how to boot this up. So how about we just boot it up first and test it and see what it can do, and then we open it and have a look. So we are ready. I connected the power supply. Let's turn it on. Plus minus 15 volts. It is using almost nothing. Okay. Ooh. Wow. Okay, this is difficult to video. So this is minus. Okay, this is plus. No. Okay. Aha! Cool! It is that easy. And then it loops. Of course it's an attenuator, there is no gain. And we can go AC or DC. How about we plug in a power supply or some voltage or what? What is the impedance or what? How do I figure this shit out? Is it 50 ohms or is it 600 ohms, right? So this is quite interesting. I don't have any attenuation on right now. The input is 50 ohms, 800 millivolts RMS in 50 ohms. Right, but okay, that is weird because now I got 1 volt RMS and I am in 50 ohms here on the scope, and if I attenuate the signal, it goes real nice and fine. So if I got no attenuation like that, okay, so there's, that means the input here is not 50 ohm, this is high impedance, and there is a buffer in here that makes the output 50 ohms, because then the output on the scope is actually accurate when I got in 50 ohms. So let's try and do this again. Instead of the output, I think we can do like this, high set, 800 millivolt RMS. So now I got 800 millivolts if there's no load on this one, right? And now look at the fun thing. I got 800 millivolts RMS on the scope, and that is in 50 ohm. So this is how it works. There's a buffer, high set in, low set out. Fantastic. So it can be used for that as well. And so this is 1 kilohertz, AC or DC is of course not a thing. And this is attenuation 10 dB, 1 dB, and 0 point. Wow, I kind of like this. I think this is very useful. Let's see. Ooh, 90 dB, huh? And I can't crank up the input. And see, here's actually a funny thing. 0 dB attenuation, and now I crank up the input. Oops, see, we got clipping, and this is 900 millivolts of input. And what happens if I just, oops, isn't that funny? Let's just give it 10 dB attenuation. So that means the attenuator is actually on the input side before the output buffer or output driver or whatever you want to call it, because look, now I can crank up the input until I get a clipping. So the clipping is about here where you see the dotted line, and that means if I remove the input or the attenuation, see, it's the same. Aha, so that is actually quite interesting. So that means 10 dB attenuation, and we are back to 790, and that is 2.5 volts RMS input. And let me try 20 dB attenuation, and now let's just crank up the input. Wow, this is really, so this is 6 volts input, 7 volts input RMS. Yeah, so this is definitely how it is. That is very useful to know that it's the attenuation is actually on the input, and it will just handle whatever you give it. Okay, that is nice. Let me try and see the bandwidth. So this is 2 Hertz input, and I'm using 10 dB attenuation, so that means we see a lower signal, and I am in AC. Now I will flip it to DC, and look, we now got a lot more input. And now it should of course go all the way to 0 Hertz to DC. So there is a DC block in here in the very low Hertz. If I go to AC again and go up to like 10 Hertz, oh, we have got almost full level. Let's go to 20 Hertz. Yeah, I think we're there now, right? I could also just go to 100 Hertz like this, and then you, yeah. All right, let's go all the way up to the maximum, see what this thing can do. Yeah, look at this. So that is 30 kilohertz sine wave. Oops, see, it's clearly attenuated here, 50 kilohertz. Let's just crank it up. So this is 100 kilohertz. Yeah, and there's 400 kilohertz. So yeah, this is definitely made for audio. This is revealed by the 20 kilohertz. There's absolutely no attenuation, and then 30, I can just barely see it, and 40 kilohertz like that. Okay, yeah. So this is full audio. So now we know that. Hi-fi thingy. All right. Let's try and open this unit. I did not expect this to be so super nice. Look at that. There's a full parallel digital interface that control each of the attenuators. And look at all those ICs. Really? That much goody goodies. I am a little bit impressed. So there's a bus that goes from each. What do you know? Look at that. And let's just unplug one of them. And then we got some ground wires on each module. And this goes to a screw terminal like this. Wow, it is really, really nice. So have a look at the back side of this thing. There's an LCD display. And a lot of stuff. Probably some, yeah, okay, some op-amps. And what do you know, where are the sexy attenuator chips? That probably, oops, sorry about that. Let's have a look. 80, 71, 15. But that's an 80 converter, right? I don't see a CPU or anything. I just see a lot of gates, counters. Wow, man. This is a very, very complicated circuit. Some op-amps and stuff. I need to Google this a little bit so I can see. There's not really any other components down there. I see a little bit of transistors and stuff like this. They have hidden on the back side. But this is a lot more sexy compared to what I imagined. And here's the logo, Wilsonics, and then 1984. Whoa, so this is nearly 40 years old. Oh, now I've been Googling a little bit, and it is right. This 80, what was it, 7115, that is an obsolete part, but it is a 0 to 20 dB attenuator, a digital controllable attenuator, and it works from 0 to hundreds of kilohertz, and it got 0.1 dB step, exactly as this product. However, this product handles many more dBs, and here is why, what they have done. See the 4053, and here's another 4053. That is analog switches, 3 analog switches in each of those packages. And also what you see here around that part, you see high precision resistors. So that will be 10 or 20 dB attenuators, and again 10 and 20 dB attenuators here for the other one. So that is, of course, those two chips, they handle the big range of attenuation. So that is what it's doing. So all the other parts around here, they handle the LCD display. So we got some counters and some stuff around all the LCD display. So it's just done with ICs and gates and stuff like that. Isn't it just amazing? Instead of using a microcontroller or something like that, they solved it all with just gates and ICs. Quite a lot of design work went into this. I could imagine this would be really expensive. And also there's a parallel input for a remote control of this, where you can handle all the attenuations and stuff. So yeah, a very nice unit, and they're beautiful. I cleaned them up a little bit. They had some stickers. I just used hot water and soap and a little bit of alcohol as well. So now it looks Really, really nice and beautiful. So yeah, that is what I wanted to show you guys. Thank you very much for watching. I hope you enjoyed this. Come back soon.